Alrighty. So for exponential and log functions, it's basically the same thing that you've been doing with quadratics and rationals and square root functions. We're just using transformations, except we have different bases. So for number 1, we have base 4. So I have my first table of values, which is going to be 4 to the x. And I'm just going to pick a couple of points, usually -1, 0, 1, and 2. These are going to be my reference points. So 4 to the -1 is 1/4, 1, 4, 16. You get the idea. And then if I were to look at my function, I know I have a reflection across the x-axis right here. I have right 8, and then I have 7 units going up. So reflection across the x-axis, right 8, up 7. Notice how this is an exponential function, so your domain will always be -infinity to +infinity. And now we just need to figure out, how am I supposed to graph this? Okay, so I'm going to show you 2 ways. I'm going to show you the graphical way, and then I'm going to show you the algebraic way. Graphically, if I were to use this, and let's say I have 0, 1, which is my reference point. And if I have a reflection across the x-axis, my 0, 1 now turns into this point right here. And then I'm going to go right 8 units. And then I'm going to go down, not down, up 7 units. So 1, 2, 3, 4, 5, 6, 7. And this is now my new point. And all I did was just use my transformations. Let's do 1, 4. So 1, 2, 3, 4 is right here. A reflection across the x-axis gives me 1, -4. I'm going to go right 8. And then I'm going to go up 7. 4, 5, 6, 7. That point right here. Then I'm also going to do, let's say, 216. I know that 216 is like all the way up here. So 216 is right here. I'm going to go up 8. So that gives me 10. Then I'm going to go up 7. So that's going to be at 9. So that's my point here. Okay. Now, also, you know that your horizontal asymptote is at 7 because it's your k value. So I might as well draw that. And then graph it, connect the dots, and you should be good. This gives me a range of -infinity to 7, and my asymptote being y is equal to 7. Now, on the right side right here, I want you to give me the new points. So these new points are 1, 2, 3, 4, 5, 6, 7, 8. So 8, and then 1, 2, 3, 4, 5, 6, 8, 6, 9, 3, and then 10, -9. And we're going to figure out, how did we get these points right here using the algebraic way? So here's the thing. If you saw with my graph, with a reflection across the x-axis, it affects the y value. Since it affects the y value, I know that my y value is just going to turn negative. So I have -1, 0, 1, 2, -1/4, -1, -4, -16. And then I have right 8 units and then up 7. Now, if I'm going to the right, that's going to affect my x values. So +8, +8, +8, +8. Then my up 7 affects my y value. So +7, +7, +7, +7. This gives me -7 and then 6 3/4 right here. This gives me 8, 6, that is right here. This gives me 9, 3, which is right here. And then this gives me 10, negative 9, which is right here. So either way, you're going to get the same answer. I do prefer using the algebraic method, but sometimes it might be easier for you to do the graphical method and just use transformations. Now, it is important to note that if you are using transformations in the graphical method, even with this too, you want to go left to right. So notice how I have a reflection across the x-axis first, then I have right 8, then I have up 7. So go left to right whenever you're doing your transformations. Okay, number 2. You have 3 times 3 to the x plus 5. And my base is 3 to the x. So negative 1, 0, 1, 2, 1/3, 1, 3, 9. My transformations are vertical stretch of 3, so that affects my y value, and then left 5, which affects my x value. Since I have a vertical stretch of 3 right here, I know that my y value is going to be multiplied by 3. So 1/3 times 3 is 1, then 3, then 9, then 27. And then with my left 5, which affects my x values, I'm going to subtract 5. So minus 6, minus 5, minus 4, minus 3. And these 4 points are going to be your points that you will graph. 2, 3, 4, 5, 6. Notice how you won't be able to graph negative 327. That's fine. On the test, you will be expected to graph your asymptote. So here, my asymptote is at 0, so y is equal to 0. My domain will always be negative infinity to positive infinity, and my range is 0 to infinity. Connect the dots, and you are good. Now, if you wanted to do the graphical way, once again, I'm going to pick 0, 1 and show you why this works. If I have a vertical stretch of 3, that stretches my y value to 0, 3. Then I'm going to go left 5. So 1, 2, 3, 4, 5. And hey, I hit that point right there at negative 5, 3. I can do the same thing with 1, 3. A vertical stretch of 3 goes to 1, 9. And then left 5, which gives me this lovely thing right here at negative 4, 9. Number 3 is a little bit tricky because you have a base of 1/2. Now, I want your bases to be greater than 0. So here I'm going to flip my 1/2 so that we have base 2. Do not distribute to the negative. Keep it like that. Remember back in Unit 1 how we had to factor out negatives inside my arguments if there was a negative in my argument. So I have 2 times 2 to the negative x minus 5 plus 5. And this gives me a transformations of a vertical stretch of 2. A reflection over the y-axis, right 5, and then up 5. Your domain, obviously, negative infinity to positive infinity, and your asymptote is at y is equal to 5. Now, honestly, here, since there's a lot of transformations going on, I would use the graphical method for this. That's what I like if you have a lot of transformations. Or you could use the algebra method, which I'll also do. But if I were to use, let's say, 1, 0, 1, 2, and 2, 4, or 0, 1, 1, 2, and 2, 4, I have a vertical stretch of 2. That's my first thing. I have a reflection across the y-axis, which doesn't really do anything since it's already on the y-axis. I'm going to go right 5. and then I'm going to go up 5. So this is my new point. Let's see 1, 2. At 1, 2, I have a stretch of 2. I have a reflection across the y-axis. I have right 5. And then I have up 5. And then finally, let's say I have 2, 4. Vertical stretch of 2, which gives me 8. And then a reflection across the x-axis. Right 5. And then up 5. 1, 2, 3, 4, 5. So it's going to be like up here. So I could also do negative 1, 1/2. That 1/2 turns into 1. Once I multiply by 2, a reflection across the x-axis, not x, y, sorry, y, right 5, and then up 5, which gives you that graph right here with an asymptote of 5, 1, 2, 3, 4, 5. Connect your dots. And there's your graph. So you can see I kept my original ones right here. Using the algebraic way, if I have a vertical stretch of 2, that's multiplying by 2. I have a reflection across the y-axis, and if you saw, if I did a reflection across the y-axis, your x values are changing. So now it turns into 1, 0, negative 1, negative 2. I'm going to go plus 5 for your x because you're going right 5, and then plus 5 for your y because you're going up 5. So this gives you 6, 6, which is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, which is this dark green thing. You have 5, 7, which is this blue. You have 4, 9, which is this green. And then you have 3, 13, which is this orange right here. This gives us a range of 5 to infinity. So that's basically a short TLDR on exponential functions.